What is microscope? It is used to see small objects. Now, right now we have two types of microscopes. We have simple microscope and compound microscope. First of all, first we discuss simple microscope. Simple microscope. Here, simple microscope. Here, what is simple microscope? It is a magnifying glass. It is also called what? Magnifying glass. Here, a short focused convex lens fitted in a metal frame provided with a metal chamber. Here, and it is hold an object like this. Here, short focus convex lens which is fitted in a metal frame provided with handle to hold it on an object like this. That is the simple microscope. Here it is called what? Magnifying glass. It is also called what? Magnifying glass. It magnifies. So it is also called what? Reading glass. Now we discuss construction of a simple microscope and working of simple microscope. Here already I told that it is a short focus convex lens fitted in a metal frame. Now this is the short focus convex lens. Now this is the focal length. Now the object is placed within the principal focus of convex lens. The object is placed within the principal focus of convex lens. On the time, here lens forms the image. Here virtual enlarged image. Here suppose OJ be the object. If the object is placed within the principal focus of convex lens, on the time this convex lens forms the image. Here enlarged. It is the enlarged image. Now suppose IJ be the image. Here OJ be the object and IJ be the image. Now here we calculate magnification of simple microscope. So anyhow, what is the use of simple microscope? Here simple microscope increases the visible angle to see an object clearly. Here what is microscope? What I told, microscope is used to see what? Very small objects. Microscope is used to see very small objects. On the time, here suppose if the object is placed within the principal focus of convex lens, on the time this convex lens forms the image. Here convex lens forms the image here on the same side, but it is enlarged. It is enlarged. Now we calculate magnification. What is magnification? Here magnification is defined as the ratio of angle subtended by the image at the eye. Suppose O dash be the optic center. Now angle subtended by the image at the eye when formed at the near point to the angle subtended by the object at the eye when imagined to be at the near point. Now suppose IJ dash be the object. We imagine IJ dash be the object. Now this object makes an angle beta. Object makes an angle beta at the optic center. Now we think our eye is at optic center only. Our eye is at optic center only. Now magnification. What is magnification? Ratio of the size of ratio of angle subtended by the object at the eye when formed at near point to the angle subtended by the object at the eye when imagined to be at the near point. Imagined to be at the near point. Suppose what is near point? Near point. What is near point? Nearest point from the eye at which the object is seen clearly. What is near point? We have near point. Near point means what? Nearest point from the eye. Near point. Near point means what? Nearest point from the eye at which the object is seen clearly. At which object is seen clearly is called what? Near point. For normal eye, near point how much? 25 centimeters. For normal eye, near point is 25 centimeters. On the time, here OJ be the object. Here IJ be the image. On the time, image makes an angle alpha at the optic center and object makes an angle beta at the optic center. Now for small angles, here we calculate now tan alpha. For small angles, tan theta is approximately equal to what theta. So what we write now, m is equal to tan alpha by tan beta. Tan alpha by tan beta. Now tan alpha how much? Tan alpha how much? Opposite side by adjacent side. What is opposite side here? Ij. Ij by here. Ij by how much here? Io dash by tan beta how much? Ij dash by O dash. From this O dash gets cancelled. We are getting Ij by Oj dash. But Oj is equal to what? Here Oj is equal to Ij dash. Oj is equal to from diagram here Oj is equal to how much? Oj is equal to Ij dash. Here Oj is equal to Ij dash. Now it is Ij dash. It is Ij dash. Now m is equal to what we write now? M is equal to Ij by Og. Ij by Og. Now triangles, here triangles IO dash j and OO dash j are similar triangles. Here triangles IO dash j dash and IO dash j and what is that? IO dash j are similar. So ratio of corresponding sides are equal. You know that in geometry you already studied two triangles are similar triangles, so ratio of corresponding sides are equal. So from that here Ij by Oj, here Ij by Oj is equal to what we write now? IO dash by OO dash. So on the time here IO dash how much? IO dash is d. Here OO dash, what is that? U. What is U? Object distance. Initially object is at OJ is object. Here what is object distance? U. On the time IO dash how much here? IO dash is d. Now OO dash how much? U. Here what we are getting now? Magnification. From this magnification is equal to we got d by u. Magnification is equal to we got d by u. Now according to lens formula, is it clear? First of all, what I am saying, what is microscope? Here simple microscope. Simple microscope means what? సూక్ష్మదర్శిని. ఇక్కడ మనం సూక్ష్మదర్శినితో ఏం చేస్తాం? ఇక్కడ స్మాల్ ఆబ్జెక్ట్స్ని చూస్తాం. ఇక్కడ ఈ simple microscope increases the visual angle to see an object clearly. Simple microscope is an instrument that increases the visual angle to see an object clearly. What is simple microscope? It is a short focus convex lens fitted in a metal frame provided with what? Handle to hold on any object. That is the microscope. Now how it works? Now this object is placed within the principal focus of convex lens. Object is placed within the principal focus of convex lens. On the time this lens forms the image here, enlarged image. Ij be the enlarged image. Ij be the enlarged image. It is virtual image. On the time here we calculate magnification. What is magnification? Ratio of angle subtended by the image at the optic center to the angle subtended by the object at the optic center when imagined to be at the near point. Imagined to be at the near point. So m is equal to what? Alpha by beta. For small angles, tan alpha is equal to what? Alpha. Tan alpha by tan beta. Now tan alpha how much here? Tan alpha is equal to what? Opposite side by adjacent side. Ij by OO dash. Ij by OO dash. Tan beta how much? Oj by here. Tan beta is equal to what? Ij dash by IO dash. OO dash. OO dash gets cancelled. Ij by Ij dash. So but from diagram Oj is equal to what? Ij dash. So m is equal to what? Ij by Oj. From this triangles IO dash j I O dash j and I O dash j are similar. So, ratio of corresponding sides are equal. So, Ij by Oj is equal to how much we got? I O dash by O dash. So, it is nothing but what? Magnification is equal to how much we got? D by U. What is D? D is the least distance of distinct vision. స్పష్ట దృష్టి కనిష్ట దూరము. D అంటే here least distance of distant vision. What is least distance of distant vision? Distance of near point from the eye. What is near point? Nearest point from the eye at which the object is seen clearly. That is called what? Near point. Now, for normal eye, near point how much? D value how much? 25 centimeters. Like that. Now, here we derive expression for magnification by using lens formula. We derive. Now, already we got m is equal to what? D by u. Now, here according to lens formula, here what we have? Here magnification, already we got now D by u. From this 1 by f is equal to what way formula? 1 by v minus 1 by u. Here we are getting, we have lens like this, we have, this is object, this is image. Both are measured opposite direction of incident rays. So, u is negative, v is also negative. U is negative, v is also negative. That is why here y negative, we calculate distances. Distances measured opposite direction of incident rays are taken as negative. That is why v is equal to minus d and u also becomes what? Minus u. So, that is why 1 by f is equal to minus 1 by d minus of minus 1 by u. From this here 1 by f plus 1 by d is equal to what? 1 by u. What we write now? 1 by f plus 1 by d. Why u is negative? Here u, v and u are negative. Why negative? We calculate object distance, image distances are measured opposite direction of incident rays. So, that is why 1 by u is equal to what we write? 1 by f plus 1 by d. So, we substitute now. Here magnification is equal to d into, here what we have? Magnification is d by u. From this d into, instead of 1 by u what we write? 1 by f plus 1 by d. 1 by f plus 1 by d. From this magnification is equal to d by f plus here d by d. D by d how much? Here suppose here we took v is equal to d. V is equal to d means what? Image is formed at near point. Image is formed at what? Near point. On the time here what we are getting? Magnification 1 plus d by f. M plus here what we got now? D by f plus 1. M is equal to how much? 1 plus d by f. 1 plus d by f. What is f? F is the focal length of convex lens. Image forms at near point. Image forms at near point. Here magnification, what is formula? 1 plus d by f. Otherwise image forms at far point. Image forms far point, v becomes what? Infinity. Here what we are getting now? If the image forms at far point, v becomes what? Infinity. V becomes infinity. On that time instead of here, instead of d what we take now? D, instead of d what we take now? Infinity. Here v becomes what? Infinity. What is v? Image distance. So, now image forms at far point becomes, it becomes what? Here v is, image forms at far point, v is infinity. V is at infinity. On that time what we are getting now? D by f plus d by infinity. D by infinity. So, d by f, d by infinity how much? 0. Magnification how much? D by f. In simple microscope, if the, what is formula for magnification? Image forms at near point, magnification is 1 plus d by f. Image forms at far point, magnification how much? D by f. Which is more? Image forms at far point, magnification is less. Image forms at near point, magnification is more. Image forms at near point, magnification is more. You remember this. Here next we have, suppose if you want to magnify, we magnify the small amounts, we are using simple microscope, but we require more magnification. So, it is not possible to magnify the simple microscope. On that time we are using compound microscope. Anyhow, in simple microscope you remember these formulas, depends on these we have problems. Simple microscope, what is this? It is also called what? Magnifying glass or reading glass. What is magnification? We have two cases, image forms at near point and far point. Image forms at near point, magnification, what is that? M is equal to 1 plus d by f. Image forms at far point, magnification how much? M is equal to d by f. When image magnification is more, image forms at near point, magnification is more. Here what is d? D means what? Least distance of distant vision. It is nothing but what we say, it is స్పష్ట దృష్టి కనిష్ట దూరము. ఇక్కడ నార్మల్ ఐకి ఎంత ఉంటుంది? 25 సెంటీమీటర్స్ ఉంటుంది. ఇక్కడ మనకు మ్యాగ్నిఫికేషన్ ఎక్కడ ఎక్కువగా ఉంటుంది? నియర్ పాయింట్లనే మనకు మ్యాగ్నిఫికేషన్ ఎక్కువ ఉంటుంది. కానీ మనకి సమ్ టైమ్స్ we require more magnification. On that time by using simple microscope it is not possible to observe it is not possible to magnify that image object. So on that time we are using compound microscope. Next we have compound microscope. But here in compound microscope we are using two lenses. So one eye lens seen. Now in simple microscope we are using convex lens, that only we are used as, that lens only used as eye lens in compound microscope. So magnification same we are taking in compound microscope also. So when you are reading, first you read simple microscope, after that compound microscope. Here if you want to do the problems in simple microscope and compound microscope, first of all you must thorough this theory. Without reading theory it is not possible to get the problems. That's why compulsory you learn theory, after that you do problems. So we have problems on these formulas only. Here what are that formulas? If the image forms at near point and far point, image forms at near point, what is magnification? 1 plus d by f. Image forms at far point, magnification how much? D by f. Magnification is d by f. In which case magnification is more? At near point only magnification is more, like that. Next we have compound microscope. Compound microscope. When we are using compound microscope, if we require more magnification, we are using compound microscope. Here in compound microscope it consists of what? Two convex lenses, two converging lenses. Here two converging lenses. One is two converging lenses. One lens we are keeping near the object, that is called what? Objective. Other lens is towards the eye, that is called what? Eyepiece. Here next we have compound microscope. Compound microscope. Compound microscope. Here it consists of two convex lenses. Two convex lenses. Now the two convex lenses are arranged with common principal axis. Common principal axis and lens towards the object. Lens towards the object is called what? Objective. Objective. Lens towards the eye is called what? Eyepiece. Here lens towards the object is called what? Objective. Lens towards the eye is called what? Eyepiece. Now this object having less focal length and less aperture, and eyepiece having more aperture and more focal length. Now suppose f0 be the focal length of object. On that time, now object is placed just behind the principal focus of objective. On that time, here this is f0 to f0. Now this objective forms the real inverted and magnified image, like this. OJ be the object, OJ be the object. Now object is placed within the principal focus of convex lens. On the time image forms at behind 2f0. Here image is I1 G1. I1 G1. First of all, construction. What is construction? What I am saying, what I told. Here when we are using compound microscope, if we require more magnification, we are using compound microscope. Here compound microscope consists of two convex lenses, two converging lenses. Here one lens we are keeping towards the object, that is called what? Objective. Other lens towards the eye, that is called what? Eyepiece. Here objective having less focal length and less aperture, objective having eyepiece having more aperture and more focal length. Now these are placed here, these two are placed at the ends of a metal tube. Now distance between the lenses, here distance of the object from the objective is adjusted with the help of a rock and pinion arrangement, rock and pinion arrangement. Now how it works? Here first of all, object is placed just behind the principal focus of objective. On the time, this objective forms the image I1 G1 at behind 2f naught, behind 2f naught. Now here this I1 G1 acts as object for a eyepiece. Here image formed by the objective, acts as object for eyepiece, Now this eyepiece forms the here virtual enlarged magnified image, Here actually OJ be the object, now OJ be the object, it becomes like this. Here suppose what we are getting now, here I2 G2 is the, here I2 G2 is the final image. It is the virtual enlarged magnified image, We take dots also here like this. Virtual enlarged magnified image. On the time, here O dash be the optic center of objective, O double dash be the optic center of eyepiece, On the time, here is it clear now? Object is placed just behind the principal focus of objective. Now what is the objective? Lens towards the object. Is called what? Objective. Now this object forms the here real inverted and magnified image, I1 G1. Now just behind the 2f naught. What is f naught? F naught represents what? Focal length of objective. Now on the time, position of the eyepiece is adjusted. On the time, here f naught be the here eyepiece. Eyepiece forms the here inverted, here what we are getting? Virtual inverted magnified image. So suppose IG, we take anything. Now IG be the final image. Virtual enlarged magnified image. We take OJ be the object, it becomes like this. We are getting big one. Here what is now? Now we calculate magnification of compound microscope. What is magnification? Same thing. Magnification is defined as the ratio of angle subtended by the image. At the near point, angle subtended by the image at optic center when formed at near point to the angle subtended by the object at optic center when it is imagined to be at near point. Like this. Now this is beta. Here tan alpha, here alpha and beta. What is alpha? Angle made by the image. Alpha represents what? Angle made by the image at optic center when formed at near point. It is nearest point, near point, like this. Angle subtended by the image at optic center when formed at near point to the angle subtended by the object when imagined to be at near point. Angle subtended by the object where? At optic center only. So m is equal to what? Alpha by beta. For small angles, what we take? Tan alpha by tan beta. Now from this, tan alpha how much? Opposite side by adjacent side. tan alpha how much? Ig by Io double dash. Here Ig by Io double dash by tan beta how much? Ij dash by Io double dash. Io double dash gets cancelled. Now we are getting m is equal to Ig by Ij dash. But from diagram, Oj is equal to what? Oj is equal to Ij dash. Oj is equal to how much? Ij dash. So that's why m is equal to Ig by Oj. Ig by Oj. Now numerator and denominator multiplied with what? I1 G1. Numerator and denominator multiplied with what? I1 G1. So from this, what we are getting now? We write like this: m is equal to I1 G1 by Oj into Ig by I1 G1. I1 G1. From this, what is I1 G1? I1 G1 is the image formed by the objective. I1, what is I1 G1? I1 G1 is the image formed by the objective. What is Boj? What is Boj? Object. Here, I1 G1 is the image. I1 G1 is the image formed by the objective. Oj be the object. Oj be the object. So that's why, what is this? It is nothing but what? Magnification of objective. And what is Ig? Ig means what? Final image. I1 G1. I1 G1 is the object for eyepiece. That's why m is equal to what? M naught into me. If we are using one microscope, one simple we are using in simple microscope, we have magnification of me only. But we are using compound microscope, magnification becomes what? M naught into me. We are using two converging lenses. That's why we are getting more magnification. Now, magnification how much? M is equal to how much? M naught into me. What is M naught? Magnification of objective. What is me? Magnification of eyepiece. Me represents what? Magnification of eyepiece. Same, just now I explained simple microscope. In case of simple microscope, image formed at near point, magnification how much? 1 plus d by f. D by fe. Image forms at far point, magnification how much? Me is equal to what? D by f. Like that. Here we calculate now, here m naught value. M naught how much? I1 G1 by Oj. I1 G1 by Oj. Now triangles. Here triangles O dash J and I1 O dash J1 are similar triangles. Here O dash J and I1 O dash G1 are similar triangles. So ratio of corresponding sides are equal. So I1 G1 by Oj is equal to what we write now? It is nothing but what? Object distance. It is object distance. What is this? This is image distance. It is V naught. It is U naught. Here image forms at here triangles I1 O dash G1 and O dash J are similar triangles. Here I1 O dash G1 and O dash J are similar triangles. So ratio of corresponding sides are equal. Ratio of corresponding sides are equal. That's why here from diagram, what we write now? I1 G1 by what are similar triangles? Here I raise now this. Now from diagram, triangle, what is that? O dash J, triangle. Next what we have? I1 O dash G1 are similar. So if two triangles are similar, what happened? Ratio of corresponding sides are equal. From this, I1 G1 by here Oj is equal to what we write now? I1 O dash by O dash. What is that? V naught by U. What is U? U naught or U? Here what is U naught? Object distance. So I1 G1 by Oj is nothing but what? Magnification. Here V naught. Here U naught is negative. Why negative? Here object distance is measured opposite direction of incident rays. That's why U naught is negative. U naught or U. So it becomes what? Here it becomes minus V naught by U. V naught is positive, but U naught is negative. U naught is negative. So now magnification, how much we got now? M naught. M naught is equal to what? M naught is nothing but what? I1 G1 by OJ. I1 G1 by OJ. We got what is that? V naught by U naught. V naught by U naught. Here, some cases, if the object is placed very close to the principal focus, on the time object is placed just near the close to the, it is placed at the principal focus, on the time U naught is replaced by F naught. U naught is replaced by F naught, and image forms at principal focus of eyepiece. On the time distance between here V naught becomes what? Here L. What is L? Distance between objective and eyepiece. Length of the compound microscope. Length of the compound microscope. Is it clear? First of all, here what is compound microscope? When we are using compound microscope, if we require more magnification, we are using compound microscope. In compound microscope, what we have here? What is construction? It consists of two convex lenses, two converging lenses. Here, two converging lenses are placed with common principal axis. Common principal axis. Here, lens towards the object. Lens towards the object is called what? Objective. And lens towards the eye is called what? Eyepiece. Now, this objective having less focal length and less focal length and less aperture, and eyepiece having large focal length and large aperture. Now, here these two are placed at the ends of a metal tube, and distance between the lenses is adjusted with the help of what? Rock and pinion arrangement. Rock and pinion arrangement. We have arrangement. Now, how it works? Here object is placed just behind the principal focus of convex lens. On the time, this object forms the real inverted and magnified image. Real inverted and magnified image. I1 G1 is the real inverted and magnified image. Now, this image due to the objective acts as object for eyepiece. Now, eyepiece forms the virtual enlarged magnified image. We take a object is OJ. మన ఆబ్జెక్ట్ ఓజే అయితే మనకు ఫైనల్ ఇమేజ్ ఎంత వస్తుంది? ఐజీ వస్తుంది. బాగా ఎన్లార్జ్ అవుతుంది ఇక్కడ. అంటే అప్పుడు మనకి ఏ మ్యాగ్నిఫికేషన్ ఫార్ములా ఏంటి? మ్యాగ్నిఫికేషన్ రేషియో ఆఫ్ సైజ్ ఆఫ్ ద రేషియో ఆఫ్ యాంగిల్ సబ్టెండెడ్ బై ద ఇమేజ్ ఎట్ ఆప్టిక్ సెంటర్. యాంగిల్ సబ్టెండెడ్ బై ద ఆబ్జెక్ట్, యాంగిల్ సబ్టెండెడ్ బై ద ఇమేజ్ ఎట్ ఆప్టిక్ సెంటర్ when formed at near point to the angle subtended by the object at optic center when imagined to be at near point. That's why alpha by beta. Now, for small angles, what we write? Tan alpha is approximately equal to what? Alpha. So, tan alpha by tan beta. So, Ig by I1, Ij by Io double dash tan theta, opposite side by adjacent side. So, again tan beta how much? Ij dash by Io double dash. So, Io double dash gets cancelled. We got now magnification, how much we got? Ig by Oj from diagram. Oj is equal to what? Ij dash. Now, numerator and denominator multiplied with I1 G1. So, we are getting I1 G1 by Oj into Ig by I1 G1. It is nothing but what? M naught into Me. What is I1 G1? Size of the image. What is Oj? Size of the object. So, I1 G1 by Oj is called what? M naught. What is M naught? Magnification of objective. And Ig is final image. I1 G1 is object for eyepiece. So, it is Me. Now, what is magnification of object? How we calculate now? From diagram, here triangles O dash J and I1 here O dash G1 are similar triangles. So, ratio of corresponding sets are equal. From that, what we got now? V naught by U naught. Why we are taking minus? Negative sign indicates what? We are calculating object distance. Object distance is measured opposite direction of incident rays. Object distance is measured opposite direction of incident rays. That's why U naught is negative, but V naught is positive. Now discuss magnification of compound microscope. Is it clear now? Now, suppose if you want to do problems on compound microscope, first of all you must thorough this theory. From that theory, if you are thorough in this theory only, you are getting problems. So, first you read this compound microscope. Now, here magnification. Suppose image forms at near point. Image forms at near point. We have two cases. Image forms at near point. Image forms at near point. At near point. Image forms at near point. at near point. At near point, here m is equal to how much we are getting? Minus V naught by U naught. ME how much? 1 plus D by FE. Here what is formula for M? M naught into ME. M naught into ME. If the object is, suppose V naught is equal to F naught. Here U naught, if the object is placed at the principal focus, near the principal focus, U naught becomes what? F naught. And V naught becomes what? L. So, on the time M becomes what? Minus L by F naught into 1 plus D by Fe. Image forms at near point. Image forms at near point. Magnification how much? L by F naught into 1 plus D by Fe. 1 plus D by Fe. Here again image forms at far point. Image forms at far point. So, on the time image forms at far point, magnification how much? L by F naught into D by Fe. D by Fe. D means what? Distance of least, what is D? Least distance of distant vision. Now, image forms at far point minus LD by F naught Fe, where? At far point. At far point, magnification how much? LD by F naught into Fe. LD by F naught into Fe. Image forms at near point. What is magnification? L by F naught into 1 plus D by Fe. What is F naught? Focal length of objective. What is Fe? Focal length of eyepiece. What is L? Length of microscope, compound microscope. D, already you know that, least distance of distant vision. Okay. Now, I explain some problems. What is given question? The focal length of a convex lens is 10 centimeter. Focal length of a convex lens. So, F is equal to 10 centimeters. Its magnifying power, when it is used as magnifying glass to form the image at near point, to form the image at near point. So, at near point we calculate, at near point we want to calculate magnification. Again second one, far point, magnification. You remember formula for magnification, just now explained. What is formula for magnification? First case, M is equal to how much? 1 plus D by F. 1 plus D by F. 1 plus D how much? 25, you remember. Capital D value always 25. So, they did not mention, so you take 25. What is D? Least distance of distant vision. Now, F how much? 10. Now, 5 5s, 5 2s. How much now? 1 plus 5 by 2. 1 plus 5 by 2 how much? 1 plus 2.5. How much now? 3.5. Magnification is 3.5. Again, here second question, for second question, magnification, image is at far point, magnification is M is equal to what? D by F. D how much? D is 25 by F is 10. 5 5s, 5 2s, same thing, 5 by 2. What is the answer now? 2.5. Here, image forms at near point, magnification is 3.5, image forms at far point, magnification how much? 2.5. Note down. Next one. Now, note down. Is it clear? Focal length given. What is question now? Magnifying power. When it is used as magnifying glass to form the image at near point and far point. Directly you remember this formula. Image forms at near point. M is equal to what? 1 plus D by F. Image forms at far point. M is equal to what? D by F. Note down. Magnifying glass. Magnifying glass is made of combination of two convergent lenses of power how much? 20 diopter and divergent lens of power how much? 4 diopters. Now, here P1 how much? 20 diopters. Convergent lens positive. Divergent lens negative. P2 is equal to what? Minus 4 diopters. Here converging lens, here magnifying glass means what? Simple microscope. Here it is made of what? Combination of two lenses, one is convergent, one is divergent, and least distance of distant vision is 25 centimeter. Now, D is 25, magnifying power. Magnifying power means what? M. Here least distance of distant vision given means what? It is at near point. At near point. Magnification, what is formula? 1 plus d by f. Now we calculate focal length. First we calculate effective power. Yesterday I told already effective power P is equal to what? P1 plus P2. Now P is equal to P1 how much? 20 minus 4. How much now? 16. Power is 16. Focal length how much now? Focal length is 100 by F, 100 by P, 100 by P. Now 100 by how much now? 16. 4 4s, 4 25s. Now 25 by 4, 25 by 4 how much? 6.25, 6.25. Now magnification, what is formula for magnification? Image forms at near point, magnification how much? 1 plus d by f. 1 plus d how much? D how much? Here 25 by, otherwise what we take? 25 by 4. So 25, 25 gets cancelled. 1 plus 1 into 4, 1 plus 4, how much now? 5. What is the answer now? Magnifying power is 5. Okay, that only correct. Is it clear? Here power, actually convergent lens, here magnifying glass made of what? Combination of two lenses. What are that? One is convergent lens. Convergent lens focal length is positive, power is positive. Divergent lens focal length is negative, power is negative. That's why total power how much? P is equal to P1 plus P2, 20 minus 4 how much? 16. Now we got how much? Focal length how much here? Here focal length is 100 by P, 100 by P. So what we got now? 25 by 4. Magnification how much? 1 plus d by f. So what is the answer now? 5. Note down. The objective lens of compound microscope. Objective lens of compound microscope produces a magnification how much? 10. Means what? M naught. Here we have, in compound microscope we have objective and eyepiece, you know that. Now objective lens of compound microscope produces a magnification how much? 10. So M naught is 10. M naught is 10. In order to get an overall magnification 100, when image forms a 25 centimeter from the eye, so overall magnification how much? 100. Where image forms a 25 centimeter. 25 centimeter means what? Near point. Now focal length of eye lens should be, we want to calculate focal length of eye lens should be. Here what is formula for magnification? M is equal to how much? M naught into ME. M is equal to how much? M naught into ME. From this we substitute now. M how much? 100. M naught how much? 10. Here image forms at near point. What is magnification? 1 plus d by Fe. 1 plus d by Fe. What is Fe? Focal length of eyepiece. Now 10 ones, 10 tens. From this, here 10 is equal to 1 plus d by Fe. From this, here d by Fe is equal to how much? 10 minus 1. Now from this, here 10 minus 1 how much? 9. Now d is equal to 9 Fe. Now Fe is equal to d by 9. D how much? 25 centimeter. 25 by 9. 25 by 9. So that only answer. Here 25 by 9 centimeters, like that. This option only there. D by 9, D value how much? 25. Is it clear? Understand? Overall magnification given, objective magnification given, but they are not asking of magnification of eyepiece. Directly what they are asking? Focal length of eye lens. So when image forms at near point, what is magnification? M naught into ME. ME value how much? 1 plus d by Fe. 1 plus d by Fe, like that. Note down. A compound microscope as a magnifying power of, as a magnifying power of, magnifying power of 100, when the image forms at infinity, when when the image is formed at infinity, image forms at infinity. The objective has focal length. The objective as focal length. The objective has focal length of 0.5 centimeters. 0.5 centimeters, and the tube length is 6.5 centimeters, and the tube length is 6.5 centimeters. Then the focal length of eyepiece is, eyepieces. We have a question like this. Here, what we have now? Compound microscope has magnifying power of 100. A compound microscope has a magnifying power of 100. Total magnifying power, m is equal to 100. When the image is formed at infinity, the objective has focal length. Objective has focal length of much? F naught is 0.5 and tube length L is 6.5 centimeters. Focal length of eyepiece, we want to calculate Fe. What is given here? Image forms at infinity. When the image formed at infinity, magnifying power is 100. So, what is formula? Magnifying power is equal to LD by F naught into Fe. You know this, when the minus, actually it is minus, so we take magnitude now. Image forms at infinity, what is magnifying power? M is equal to what? LD by F naught Fe. From this, we substitute now 100, tube length of much? 6.5, D of much? 25, F naught of much? 0.5. We want to calculate Fe. Now this cancel, 5 point gets cancelled, 5 ones, 5 fives, 5 13s, 25 ones, 25 fours. From this, what we are getting now? 4 Fe is equal to 13. Now Fe is equal to what? 13 by 4. How much? 4 ones, 4 threes, 12, 1.0, 10, 4 twos, 8, 20, 3.25, 3.25 centimeters, 3.25 centimeters, like that. A dispersion, yesterday already explained. Now, here we have question, if the ratio of dispersive powers, dispersive powers of the materials of two prisms be 2:3, prisms be 2:3, and ratio of angular dispersions produced by them is 1:2. Then the ratio of mean deviations produced by them, we have question, then the ratio of mean deviation ratio of mean deviation produced by them, is, we have a question like this. Here, if the ratio of dispersive powers of the materials of two prisms be 2:3, dispersive powers omega 1 by omega 2, how much? 2:3. And ratio of angular dispersions of produced by them. Angular dispersion means what? Angle of deviation. Here we take theta 1. Here theta 1 by theta 2. How much? 1:2. We want to calculate ratio of mean deviations. So, we want to calculate mean deviation dm1 by dm2. dm, what is dm? Mean deviation. So, what is formula? We know that angular dispersion is equal to what? Angular dispersion is dispersive power is equal to what? Angular dispersion by mean deviation. Angular dispersion by mean deviation. We take theta m also, no problem. Theta m. Theta m means what? Mean deviation. Now, dm or theta m. From this, here what is dispersive power? Dispersive power means what? Ratio of angular dispersion by mean deviation. Ratio of angular dispersion by mean deviation. From this, here what we are getting now? Omega theta m is equal to theta. Now, theta m is equal to what? Theta by omega. From this, theta m1 by theta m2. Theta m1 by theta m2 is equal to what? Theta 1 by theta 2 into how much here? Omega 2 by omega 1. Theta m1 by theta m2 how much? Theta 1 by theta 2 into omega 2 by omega 1. Now, from this, here theta 1 by theta 2 how much? 1 by 2 into omega 2 by omega 1 how much? 3 by 2. So, what is the answer now? 3 by 4. Ratio of mean deviations how much? 3 by 4. Is it clear? Here ratio of dispersive powers given. Dispersive powers how much? 2:3. Ratio of angular dispersion is also given. They are asking mean deviations. What is formula for angular dispersion? Angular dispersion is equal to dispersive power is equal to what? Ratio of angular dispersion by mean deviation. Ratio of angular dispersion by mean deviation. So, we do cross multiplication. Omega into mean deviation is equal to what? Angular dispersion. So, mean deviation is equal to what? Angular dispersion by dispersive power. So, what we got now? 3 by 4. 3:4 only answer. Now, 3:4 only correct. Next one, we have note down. We have next question. Next question. Dispersive power. Here, dispersive power of the material of a prism is dispersive power. Dispersive power of the material of a prism is 0.0221. If the deviation produced by it for yellow color is 38 degrees. Now, here find the angular dispersion between the red and violet colors. Then find the angular dispersion between red and violet colors. Angular dispersion between red and violet colors. We have a question like this. Here, what is given? dispersive power of the material of a prism is given. Dispersive power. Here, dispersive power of the material of a prism is 0.0221. Now, omega is equal to 0.0221. If the deviation produced by it for yellow color, so that is mean deviation. Mean deviation how much? Theta mean, D mean is equal to what? 38 degrees. Find the angular dispersion between red and violet colors. Angular dispersion between what? Red and violet colors. So let it be theta, angular dispersion, theta. What is formula? Here angular dispersion, dispersive power is equal to what? Angular dispersion by mean deviation. Now, here, now theta is equal to what we write? Omega into theta m. Omega how much? 0.0221 into 38. Here multiply now. Here 221 into 0.0221 into 38. Multiply now. You are getting around 0.84 degrees. Here it is very simple problem. Here, so first of all you learn dispersive power, angular dispersion, mean deviation. If you are reading, so you are getting this formula, it is simple. Otherwise, if you are not reading, problem, if you are not reading theory and if you are not reading problem, it is difficult. So in examination, nearly 60 to 70% paper, normal paper in any exam, they are giving normal questions only. So they are checking, you know, concept or not, like that. So that's why you read all synopsis and theory and you do problems. So what is that? Here what is question now? Angular dispersion, how much we are getting? Red and violet color. Just we multiply angular dispersive power into mean deviation. Theta mean means what? That is nothing but what? Yellow color. Here in theory already explained. Mean deviation of red and violet color. Mean deviation of red and violet color is taken as what? Yellow color. So theta m is equal to, what is that? Yellow only, D yellow only. So what is the answer now? 0.84 degrees, like that. Now, so that's why anyhow you must thorough all synopsis and you do problems.